Hello everyone, I hope you've had a good few days since we last communicated with one another. So, by now, those who have been following me have most likely become at least novice users of Python. Well, today we're going to step it up a bit and apply our knowledge of the turtle module within Python to create a repeated pattern and switching colors. Okay, so I've titled this project the Coded Coasters. Alright, so let's move forward. So the task at hand is to use the turtle module to create this image here. And not only that, we're going to repeat this image 4 times up and 4 times across to create a 4x4 of this image. Alright, so that means this image is considered a 1x1. Alright, and let's see here, going forward. So the image must be dual colored and the colors must switch per square. And the code must be legible to novice Python users. Alright, so moving forward. So if we're successful, we will receive this image right here. So you can choose whichever colors you want. I was drinking Arizona iced tea, so I chose light green and light pink. Alright. Boom. So if you're overwhelmed, let's break it down. Alright. Every journey begins with a single step forward. Okay, so we're going to break it down to these basic shapes here. Okay, and once we've created them, we're going to combine one to another, then loop them, then loop that again, then loop that again, then loop that again. You see where I'm going with this. Alright, so let's categorize here, okay? We're going to first make a function named aTriangle to make this shape. Then a function bPoky, because this is like a pokey polygon. And then combining that plus some basic setup, we're going to loop it so that this will loop 4 times around to create bottom left 6x6. Okay, and I chose to say 6x6 because this is 6 grid by 6 grid. This quote unquote 1x1 image has 18 grids across and 18 grids down. So that's what we've done. Okay, so let's go back. Alright, so we have aTriangle, bPoky, bottom left 6x6 or BL 6x6, and then we're gonna loop that 3 times across to have BL 6x6 loop. Yeah, I'm pretty straightforward with my naming. And then after that, we're gonna loop that all the way up 3 times to create BPL, which is our basic pattern. And this pattern I've named L, or actually, you know, my teacher named it L. So that's that. So if you're confused, this slide here will have reiterated what I said. This combined with this, loop 4 times creates BL 6x6. That loops 3 times across, creates BL 6x6 loop. And that one loops 3 times upwards, will create BPL. It actually isn't upward the way that I've done it, but just know that it's a for loop in range 3. Okay. Now we're gonna start stacking our loops. Okay, we have all our basic patterns. The work from here is very easy. Now we have our basic pattern. Now we're gonna loop that 4 times across, okay, to create a 1x4, and then loop that all the way down to create a 4x4. So BPL to BPL horizontal to OP, which is our overall pattern. Alright, so there we go. So the disclaimer, okay, is actually a link for you to watch this video, which is, I guess, redundant because you are already watching this video. Alright, so let's get cracking with our code, shall we? So most of you know the basic turtle setup. Import turtle. I chose to do math in this because I want to use the square root instead of like to the power of 1/2. So I imported math as well, and set up the screen, set up the color. Before I wanted to like mess around with colors, but I ended up going with white. It's easier on my eyes, as this took me more than a few hours. And then I've named my turtle Smart and set its speed to 0, which is the fastest speed if you're not using Tracer. Okay. For some reason, I wasn't able to get Tracer to work this time around. I will be troubleshooting that. I hope you excuse me for that. All right. So going forward. Now, I've done my research, and 1 inch is actually 96 pixels. And so since I'm doing, I'm drawing grid by grid, I've decided to do inch divided by 18. Because, I mean, if you think about it, it's a 4x4, so 4 inch by 4 inch. And I'm drawing the basic pattern first. So that basic pattern is an 18 by 18, so I'm doing inch divided by 18. I set 150 because I have quite a big screen and it's hard to see. So for our purposes today, we're gonna leave it at 150, or actually perhaps a larger number, like maybe 180. But if you want to print this out without having to scale, set your inch value to 96. Okay. All right, moving forward. So the very first thing I've done is to set my turtle position. And so, when you start drawing out a turtle, it will, pardon me here, it will draw like starting in the center of your window, okay? And then it'll draw whichever direction you tell it to, but that's where it starts. So we don't want that. So I set mine 2 inches back to the left, so -2 times inch. Okay, most of you know how to do this here. T dot up, meaning pen up, because I don't want it to mark anything at that point. And I've moved it there, then set the turtle back down so it could start marking stuff. Okay, so this is our only positional setup, I think, outside of a function. Okay, or I guess a function by itself and not used in another function or a loop. So, all right, moving forward. Now we have a triangle. Okay, remember when we talked about that from the beginning? A triangle right there. Okay, so essentially, since I'm starting at the center of the screen, which I've set at the very far left, I'm choosing to start right here. What that means is, a stock turtle, meaning a turtle that's unmessed with, is in the center of the screen or at its beginning position facing to the right. So I'm moving this forward 2 grids. So it's going to look like 2 times grid, right? Because I've already set up what grid means. And so 2 times grid, and then left turn 135 degrees, as you can see here. To move this way. And now this is where the, I guess, import math comes in, right? Because now I want to do some Pythagorean theorem, right? A squared plus b squared equals c squared. So c equals the square root of a squared plus b squared, right? Yeah, so so let's go ahead and look at that coding here. So I'm beginning to fill here. There's different ways to fill, but you can kind of mess around with that and kind of get the same results. I just did it this most simplest way I know how. After this triangle is drawn, I want it to be filled right away. So I've already began filling here. T dot begin underscore fill, meaning the color, the turtle will fill whatever shape it draws, right? So then I'm going forward 2 grid, like I said. Okay, I'm going forward 2 grid, then left turn 135. Then forward the square root of 2 times 2 grid to the power of 2, right? Because this is 2 grid, so a squared plus b squared, because a and b is the same here, you can just multiply by 2 and then square by 2, or I mean squared it, right? Okay, so now I do another left turn at 135, right? Then move down 2 grid. Left turn to reset my turtle's orientation, then end fill. And that is a triangle of T. Okay, so now if I were to run this by itself, it will draw this shape, okay, and fill it in black because I haven't called any color, as you can see. There's no color here, right? So this will fill in black, but that's okay because we will set conditionals for filling later, right? So then moving forward, let me eliminate that unnecessary space there, save some data. Okay, now we're gonna move on to drawing the next shape, right? It's this pokey polygon here. I should have called it crown now that I look at it in yellow. But anyways, so the pokey polygon of T. So again, I'm beginning to fill, and notice that I'm filling these darker shades. Okay, it seems like the wise choice. I could have done the opposite. The code would have looked a bit different, but not too much. Okay, so anyways, where was I? We were here, right? So now to draw just this shape alone, imagine that this shape is actually flipped over to the right. So so flipped 90 degrees to the right. I actually have some examples here. Aha! Whoa. So if you look at this shape, it's actually not exactly it. It's actually, you know, supposed to be flipped the other way around. But anyways, you will get it once I explain in further detail. Let's go back to here. So we can, whoa, my apologies guys, I forgot mouse wheels. There we go. Mouse wheels, scroll slides. Who would have thunk? All right. Now this shape right here is gonna be drawn starting, let's see, right here, right? And oh, you know, it's actually a very good example that I showed. Let's go back. Starts right here. It's gonna move forward 1 grid, left turn 45 degrees, forward 1 grid, right turn 90 degrees, forward 1 grid, left turn 90 degrees, forward 1 grid, right turn 135 degrees, forward 1 grid. Okay, so where did I go? The picture is a little bit skewed actually, so let me go back to the code here. So since technically this is a diagonal, you would have to do Pythagorean theorem yet again, right? Where did I put that? So see that? Forward the square root of c squared for this 1 grid, then this, then this, then this, and that. So let's go ahead and look at our code to match up what we're doing, okay? Alright, so begin filling a color. It's gonna be in black the first time around. So here we go. Forward the square root of 2 times grid to the power of 2. That's this right here. Then left turn 45 degrees. Move forward 1 grid. Left turn 90 degrees. Okay. I'm sorry. Right turn 90 degrees. Forward 1 grid. Left turn 45. Forward this much, right? Right turn, left turn. So you can see what I'm doing, okay? Now this is just basic movement. It's all about understanding your orientation, okay? Now here's the cool part, right? As of right now, if I were to just run this function by itself, it will show you that pink image I showed you previously, where it's on its flat side. So this side right here is actually on the bottom, and this side right here on top. Well, because I haven't set its position yet. Right? And also know that once I start drawing this, my turtle will have to be right at this point. So 3 grids to the right of its starting position and turned to the left 135 degrees. Okay? So that's what this function is for. Set position for Pokepoly. Right? But I noticed I haven't done anything with that yet because I'm going to do it. Okay? In here. It's very interesting how I do it, so watch it out. The very next step is to understand that once you have, if you were to have combined this and that and say everything is nice and fancy, you would have to set it up in a way where the turtle will loop around like so. So what that means is I'm having to draw this pattern right here. Follow my mouse. Okay. 4 times around to create BL 6x6. So that means that my turtle would have to be in this position facing upwards in order to repeat this pattern that way. And when that's done, my turtle has to be here facing to the left to repeat this pattern that way. So to the left. Okay, and then again, turtle have to be here by the time that's done to go downwards. So facing down. And so that's what set position BL 6x6 is for. I am essentially making sure that once a triangle is ran and set position for Pokepoly is done, okay, then my turtle will do all of this, okay, to make sure that it's in the correct position and orientation. So it will be at the corner, the next corner facing upwards, right? Moving forward, see what I've done here? This is running a for loop in range of 4. Okay, so 1, 2, 3, 4 for a triangle, so little triangle here. Then I set the position to draw this Pokepolygon here. Then I set my bottom left 6x6 position so that the turtle is at the corner facing upwards, facing in the right direction for every loop, right? Boom. Run that and you will have the basic pattern BL 6x6. And then after that's done, outside of my for loop, I'm choosing to move forward 6 times grid. So 1, 2, 3, 4, 5, 6. So by the end of this, okay, by the time this is all done, my turtle will be here facing to the right. Okay. So by the time I have this whole shape within this orange square here, my turtle will be at the corner facing to the right. That way, okay, I can do my overall pattern L. Does that make sense? Now, look at this. BPL. Wow. Oh, I'm sorry. First, we'd have to do our 6x6 loop. BPL 6x6 loop. So essentially, I'm just repeating this over 3 times. Okay. So we can see our code here. Again, you can look at the code for more details. But essentially saying, take this, repeat it 3 times. Literally, because I have set up my turtle so that it's right here. Right? So remember, we begin right here. And if so, by the time I'm done, I'm here. That means I can begin again very easily and end up right here. Begin again very easily and end up right there, right? So that's what BPL 6x6 loop is all about. Okay, now I can do BPL, right? Now that I have this bottom pattern here, now I'm gonna loop it, you know, upwards. Very easily done. So when I'm done with my BPL 6x6 loop, I'm setting my position. Okay, come to think of it, I could have done this right here in a function, right? But maybe we can get away with just leaving it within this for loop here. Okay, so essentially saying what this is doing right here is to set my turtle in a way so that it will let's see, it moves back 6 grids. So that means I'm going all the way back over here. Oh, I'm sorry, I'm going over here. And whoa. What am I doing? My apologies. This right here is actually making sure that my turtle is here. Okay, I'm sorry for the mishaps. Okay, my turtle is at the corner facing to the right every time I complete the BL 6x6 loop. Oh no, actually no. This is making sure that I end up right at the bottom corner of BL 6x6 loop every time. I mean, if you think about it, I start right here. I draw orange, then I draw another orange, then I draw another orange to create this green, right? To create BL 6x6 loop. So if I want to loop that, I want to go back to its quote-unquote origin of the draw. So by the time the first loop is done, I want my turtle to be here. I'm really sorry for that mistake. So I want my turtle to be here, and then by the time the second loop is done, I want my turtle to be at the bottom of that, which is here, so that it can draw BPL. So 3 of these green loops, BL 6x6 loop, will create BPL. Yeah. Finally, there we go. So that's why it's under the function BPL. It needs to reset itself in the correct position and orientation to repeat the green loop. Alright? Let's move forward. Now that we have BPL, we're gonna create BPL horizontal. So this will move forward this way, right? Repeat itself 4 times using the same technique. Now my BPL, by the time I'm done with my BPL, I will be at this position, right? Let's zoom in on that here. My turtle will be right here facing to the right. So I have to set that position so that I can create the for loop. Now essentially saying I'm using the same technique, so therefore I want my turtle to begin here facing to the right and end here facing to the right. Very simple. So that's what this setup is for. Okay, and as you will see that you see that I put it in right here. Okay, and since I put it in right there, boom, moving forward. So this will loop, get done with drawing the basic pattern or BPL, and end up right here, then draw it again, right? So that's what BPL horizontal is. Okay, and now this is where things get interesting. Now I start to color. I'm saying that for I in range 4, so repeating this pattern 4 times, if I is equals to 1 or is equals to 3, make it make the draw line light green and make the fill color pink. And if not, then do the opposite of that. So since there's only 4 instances in this loop, so if 1 is 1 and 3, meaning 2 out of the 4 is one condition, that means obviously the remaining options will be used for the other conditions, right? So no need to put booleans right here because this is already half of all of our possibilities. So if not this, then this, right? Therefore, looping BPL 4 times. Okay, moving forward. Now I'm gonna have to set up my position so that my OP, my overall pattern, can be drawn. Now, what I've chosen to do is to go to draw BPL. To draw BPL like so. I am drawing here. What am I saying to you guys? Right, so I'm drawing it for looping from here going forward, and then reorientates and go up here and for loop that way, and reset down here and draw again. Okay. So my apologies for the jumping of screens. Again, I'm starting, I believe, with this one. Okay, I might have switched the colors around before I made the video, but we should get something very similar to this. So I'm looping BPL 4 times this way, setting my turtle so that it starts right here and draw this. See what I'm saying? So it's drawing upside down now. Right, so that's why it has to be here and then facing to the left, because that's the opposite of being here and facing to the right. So I've set it so that once this is all looped, the ending position is here facing to the right. I'd have to set it up here and face to the left and repeat. So I only do this loop twice, so to make 1, 2, 3, 4, 5, 6, 7, 8. So loop BLP horizontal once, twice, okay, and then reset down here. Then after that, I'm gonna set another position to be down here. Okay, I'm sorry, to be down here, so that it would do the exact same thing again. Does that make sense? So I'm gonna go down here, loop 4 times to make BLP horizontal this way, and then go up here and loop twice. So BLP horizontal looped once and twice this way, then going down here once and twice this way. You can see that in my code. You can examine exactly what I did for the position settings. It's just left turn, right turns, and forwards, to be honest. So you can just look at that in detail. But anyways, here we go. See what I've done here? For I in range 2, right? I'm gonna do all of this because all of this sets my positions, right? So I start here, go this way, and then go down here, go this way. If that makes sense. So this, follow the mouse, then jumps down here, do this. Alright, that's it, folks. Thank you so much for your patience in watching this video. I hoped I was able to show you a thing or two. If not, please just go ahead and email me and we will have a detailed conversation about it. Once again, my email is locging@gmail.com. My apologies because I am quite tired. But other than that, I hope you enjoyed the video. Thank you so much for watching. Take care. Bye bye.